A warm good evening to all present here. Respected Dean School of Physical Sciences, Sir Professor Chiron Bhattacharjee, respected Head of the Department of Physics, Assam University Silchar, Professor B. Indrajit Sharma, respected Chief Guest, Mr. Kishan Chore, ACS, Assistant Commissioner cum Magistrate, Kachar District, respected resource persons, Professor A.K. Shen, Department of Physics, Assam University Silchar, Professor C.R. Bhattacharjee, Department of Chemistry, Assam University Silchar, Professor Parthankar Chaudhuri, Department of Ecology and Environmental Sciences, Assam University Silchar, Dr. George R. Carey, Department of Education, Assam University Silchar, Dr. R.K. Mahato, Department of Education, Assam University Silchar, respected convener of 36th National Science Day celebration, Dr. Bidan Mohanto, Department of Physics, Assam University Silchar, respected coordinator of the event, Professor Othri Deshamukko, Department of Physics, Assam University Silchar, respected faculties and my dear teacher participants. I, Ms. Gulabsha Chaudhary, on behalf of the organizing committee as well as the Department of Physics, would like to welcome you all to the today's event, Making Science Teaching Interesting at School Level, which is a workshop organized for the school teachers in line with the several events organized as part of the 36th National Science Day celebration. In today's events, we have a series of 5 invited talks by the resource persons. I am sure the participants will make the most benefit out of the talks. So without further ado, I request Dr. Bidan Mohanto, convener of the 36th National Science Day celebration, for the welcome address. Sir, please.
Thank you, Gulabsha. Greetings and good evening to all the participants present here. I welcome the Chief Guest, Assistant Commissioner, Mr. Chorai ACS, to this program. The Dean of Physical Sciences, Professor C.R. Bhattacharjee, sir, is always very encouraging and supportive of our programs. Warm welcome to you, sir. We are also expecting the Dean of School of Education, Professor Bhattacharjee. Maybe he will be joining very soon. And I thank all the resource persons for sparing their valuable time to make this program useful for the school teachers. We have the resource persons with us, Professor A.K. Shen, Department of Physics, Professor Parthankar Chaudhuri, Department of Ecology and Environmental Science, Dr. R.K. Mahato, Department of Education, and Dr. George R. Carey, Department of Education. The Dean of Physical Sciences, Professor C.R. Bhattacharjee, has also given consent to be a resource person. Thank you again, sir. So this workshop for school teachers was conceived while we are making plans for celebrating the National Science Day. So as part of the celebration of National Science Day, we planned several competitive events for the schools and college students. And then we thought, since we are arranging so many programs for the students, why not we have some event where we can directly involve the teachers also. So thus came this idea of this workshop, which will have direct bearing on the teachers as well as students. So we know that the students are mostly motivated by the teachers at the school level. So when kids are young, the ideas, interests, and motivation that they get from their teachers remain imprinted in their mind lifelong. The school teachers perform the most important role in shaping the future of the students. The fact is that the direction that our future generation will take are mainly shaped by the school teachers. And thus the responsibility of generating scientific quests in young minds largely rests on school teachers. So I urge upon the teacher participants present here to get the maximum out of the lectures delivered by our invited speakers. All the resource persons are highly experienced and you will be greatly benefited and enriched by them. And lastly, I thank Professor Othri Deshamukko, who is the coordinator of this program. It is because of her hard work and tremendous effort that this program has materialized today. So I have a request for the teacher participants here. Now, while attending the lectures, you please keep an eye on the chat box because we shall share the feedback form there in the chat box. So submitting the feedback form is mandatory because it will serve as your attendance. So please keep mind in that. So with this, I welcome you all in this program. And now it is over to Gulafsha again.
Thank you, sir, for the detailed information. Now, I would like to request Professor B. Indrajit Sharma, Head of the Department of Physics, to address the gathering. Sir, please.
Thank you, Gulabsa. Thank you, Gulabsa. Honorable Chief Guest from the Education Department, Government of Assam, respected Dean, School of Physical Sciences, invited speakers, Dr. George R. Carey, Professor Patankar Chaudhary, Dr. R. K. Mahato, and my respected colleague teachers, Professor R. K. Sen, Professor Ati Desamukhya, Dr. Bidan Manta, and their participants. To this program, Making Science Teaching Interesting at School Level is a continuation of our National Science Day program. I congratulate Professor Ati Desamukhya, coordinator for today's program, for successfully organizing. I had emphasized on the purpose of celebrating National Science Day in terms of our responsibility to bring awareness to people about the importance of science in our daily life. This program is such an important. I must mention that it is the main feeling of the authors of science enthusiasts among the school children through their direct teachers. We are having 5 invited speakers that will discuss on the main themes, and we are ready to listen the talks. Without delay too much, with this, I thank once again the entire team for organizing this year National Science Day. I apologize that I am joining from my inside car, so my video is not in good condition. Thank you. Thank you, sir. Over to Gulab sir.
Thank you so much, sir. I see our chief guest has joined us. So, on behalf of the organizing committee, I would like to welcome Mr. Kishan Chorai, SCS, Assistant Commissioner cum Magistrate, Kachar District, for joining us in this event. So now I would like to request Professor C.R. Bhattacharjee, Dean School of Physical Sciences, to address the gathering. Sir, please.
A very good evening to all the participants and honorable chief guest for this evening. The program with the science teacher, head department of physics, and the organizers of the program, particularly Professor Tridashmukho, and all the resource person and dear participants, the science teachers. In fact, it is a moment of great pride for us in the school that the Department of Physics is leading all the way in terms of organizing several such programs, starting from touching the school levels to the top research level. In fact, the program on National Science Day was celebrated with much of fun fair, but here it's a new concept that that Science Day is not really restricted to 28th February. In fact, it is a kind of a continued effort on the part of all those who are concerned in the promotion of science and scientific pursuits. So it is in this context, it is I really compliment the department for taking up this unique project to touch the science teacher of the district, because I know when organizing a program of such nature, it is indeed very difficult to gather people in such kind of platform, because it is always a kind of a challenging task actually. So, but this background work is a lot of background work to be done, and normally we are not always ready to give this amount of hard work. But today I'm very happy that quite a large number of people have joined already this evening, and I'm looking forward to a very interactive session. And I'm sure that not only students, when it also provides us a platform to interact with science teachers, and so that there is a channel which opens up for communication amongst the all science professional, because I think science teachers who touches the children at very young age, they are faced with most complicated challenge rather than people who actually teach science at the highest level. So it is therefore equally important that through this interaction, the science, the resource person and the science teachers engaged in teaching science to the school children's interact profitably and find out innovative ways to actually promote science and scientific teaching, and in turn our country would be benefited. So I look forward to a very interactive session forward, and once again deeply record my appreciation for this initiative by the Department of Physics and the organizers for arranging this beautiful and very meaningful program in the pretext of National Science Day. So I wish the organizers every success in this program. Thank you very much.
Thank you, sir. Thank you for your valuable words and for always encouraging and motivating us with your words. So now, as I already said, we have a chief guest amongst us to grace our event, Mr. Kishan Chorey, ACS, Assistant Commissioner, Executive Magistrate, Kachar District. I humbly invite Mr. Kishan Chorey to speak a few words. Sir, please.
Thank you very much. And then I like the way you have introduced. And then so that I'm very thankful. And also I would like to thank everyone, each professors, and then even the participants. I guess there might be students. So because I heard that sir has mentioned about mentioned the students. Though I don't know each of you personally, but it's a very fortunate for me to be as a chief guest. And I would like to say that I was also a student of Assam Universities, and then I was in the Department of Social Work. So it is a very great experience, and thank you very much again. And before I speak something, and then I would like to say something about I have known the teachers, and then I really respect all professors and lecturers and all the non-teaching staff even of the Indian university. But I didn't get time yet to visit. But once I will visit the university, and then I would like to have a program and then interacting session with the students of Assam University. And then before I speak on, I think Professor Ashok Kumar Sen, the Department of Physics, he is present, and then Professor Chiron Bhattacharjee, who is again the professor of Department of Chemistry, and then Professor Parthankar Chaudhary, Department of Ecology and Environment, Dr. Ram Kumar Mahato, Department of Education, and then Dr. Ramit George Carey, who is a professor of Department of Education again. So I would like to say that regarding science, because as you have already mentioned, and then many of us know that when we talk about National Science Day, it is celebrated on 28th February every year. But as sir has a bit ago, he has mentioned about that every day the science has its own identity, which is also considered to be a science is looked with a sense of objectivity which the science has. So every day from the very morning till evening, and even from the inception of human being, we have always seen the science, the contribution of science in our everyday life. So choosing a topic for the students that how to make this science subject more interesting, this is a very which is very interesting also, which is very useful for the students, that I think. And also because what we say that, because if we see that many students, means let's talk about the community level, we see that generally a student fears scientific, you feel science subject. Let's consider mathematics also. So even me personally, I was, when I was a child and then when I was a student, I used to fear these two subjects mainly. And then our parents also used to focus mainly, like if a student doesn't study well in this subject, then he or she may fail. So we see certain things which we deal with this subject. But what I mean to say is here, what I mean to say is the importance of subject need to be felt to every student as well as the students and then the parents, because this science is not a subject which need to be feared. Often it should give, means it is subject which gives the opportunity of our daily lives. Because the moment we see that today we are in the virtual platform, this is also a gift of science. And then if there is no science, I believe that there will not be any development in field of economic, also in the field of medical, and whatever we see, everything which are the important resource of a human, we will not see such type of development. And if we can see that the development of the economy, the one of the pillar that I believe, that is science. And then I would not like to extend much saying about the science, because there will be a discussion on this platform. So saying this, I would like to conclude, and then I would like to hand over to the moderator. And thank you very much. And then thank you to everyone.
Thank you so much, Mr. Chori. It is great to know that you are an alumni of this university, and the program you have mentioned, we would be happy to cooperate in any way possible. Thank you for your valuable words, and we are grateful for your time. So with this, I would like to conclude the inaugural session here and move on to our technical session. The first invited talk will be delivered by Dr. George R. Carey, Assistant Professor, Department of Education. Before offering the mic, I would like to give a brief introduction about Dr. Carey. So, Dr. Remy George Carey is an Assistant Professor in Department of Education in Assam University, Silchar. Earlier, he worked at Ansar Training College in Trichy. A postgraduate in chemistry, Dr. Carey has a specialization in polymer chemistry. Sir, please, I would like to offer you the platform. And participants, kindly turn your microphone and camera off, and there will be time will be provided for interaction session. You can type your question in the chat box, or you can raise hand and ask your question. So I'd like to offer the platform to Sir Dr. Carey.
Thank you, Gulafsha, and very good evening to all the participants, respected participants. And before starting, before the interaction, I will just extend my gratitude to the authorities, like the coordinators of this program, especially to the physics as well as the chemistry, like the physical science department, School of Physical Science, as well as my parent department, the Department of Education, and all the authorities and the coordinators. Thank you very much for inviting me for this session, for this program. And today, within half an hour, I'll be just briefly discussing with you about the different alternate conceptions. Especially all of you are science teachers, and you must be knowing about this concept. I'm just putting it in a nutshell. I would like to present it, and I would like to see that the students could be, or the children could be able to manage with these alternative conceptions, whichever they are bringing to the classroom. And for the purpose, I'll be using my slideshows, and I'm just presenting. Give me 1 second. I hope the presentation is visible now.
It is visible, sir.
Yeah, thank you. So I'll be about the alternative conception only I'll be speaking, and briefly I'll be explaining the things. So when we are talking about the concept of alternate conception, we know that it is there everywhere, but many times we fail to catch that alternative conceptions which the children are bringing into the classroom. These are the ideas which the child is having, or they are pre-existing notions about many things, because the children are coming from the family, from the society they are coming, and when they come to the school, or even before coming to the school, they are interacting with the people, and the knowledge they are gaining from different sources, they are gaining the knowledge. And about everything under the sun, they are getting knowledge from people around them, maybe from grandmothers, maybe from grandfathers, from parents, or from siblings, or from surrounding, from every places they are getting. And here what happens is that they are learning many ideas, or they are getting many ideas and beliefs, but many of them are not matching with the scientific principles, or which the science says, or these are the ideas which has a mismatch with the scientific explanation of any phenomena, or any concept, or any construct under study. So this mismatch, we used to call it as alternate conception. So within alternate conception, there are different types of alternative conceptions are there. Out of that, mainly what is that, we will be coming across the naive concepts as well as the misconceptions. So many times people used to say everything as misconception, but all of the things are not misconceptions. The broader term, or the umbrella term, is alternate conceptions, and within that different types of concepts are coming. Like naive concepts are the concepts which are somewhat, it matches with the scientific explanations, or maybe you can call it as partially correct or something like that, but it is not the exact concept, or it is an alternate concept. And when you are talking about the misconcept is totally wrong from the scientific explanation. That science says something, and this misconception says almost the opposite thing. You can see that I have given some example, like naive concept, energy. The kids, even though they don't know what energy is, they know that something it is there. Energy is a thing, or it is something which help us to do the work, or something like that, or whatever we are doing, or we are having high energy, or we are active. All these things are naive concept. We cannot say that, or outrightly we cannot reject that as a misconcept. It is just an idea they are having. On the foundation, we can do it further, or we can develop them further. And when we are talking about the misconception, what happens is that this is almost wrong. The concept is almost wrong. Like people or the children used to say that when we are doing some activities, and when we stop the activity, it is because we are having no energy. There is no condition like no energy. If there is no energy, then you know what will happen. So, and again, when we are taking rest, the children feel that, okay, this rest is actually, we are regaining our energy. While taking the rest, we are regaining the energy. This is actually a misconcept. You cannot build further on that. That has to be caught, and it has to be removed from the brain, or the cognitive framework of the child. You can see that this naive concept happened before the instruction, or when the child comes to the class, or when the child starts to learn a concept. Before learning that concept, the idea what the child bring about that concept are the naive concepts. But whereas misconcept happens when the child started learning a concept, and while learning the concept, he has understood, or she has understood it in a different manner, and that lead to the misconceptualization, or what is it? It is really it will act as a roadblock for further learning of the child. So how this is happening? We know that this can be explained with the psychological theory, or the school of thought called constructivism, as proposed by even Vygotskian theories, and all those things we can take over here. So the constructivism has an idea, or has an explanation, that how these alternate conceptions are having. Because what happens is that we know that the children are constructing. The constructivism says like that the children construct their knowledge. You cannot teach anything, or you cannot put like in a spoon, or like a capsule form, or in a rote memorization pattern. You cannot put anything into the brain of the child. Child has to construct the knowledge. Otherwise the knowledge will not be valid. Like I have also experienced, like after the first semester examination, and when they are entering into the second semester, and within 1 or 2 months, if you ask something related to the first semester, they might have forgotten that. Because why it is happening is that it is only rote learning. The knowledge is not constructed. So the children, when they are interacting with the people and the surrounding, they start constructing their own knowledge from the experience, like touching the candle or something like that. They are, through the experience, or like that, they are getting the inputs, or the knowledge they are developing, and they do all the experimentations and everything they will be doing. But the thing is that they are not the pure real scientists, and they don't know the exact procedure of science, and nobody is there to correct them in a proper manner. And sometimes what happens is that those who are trying to correct them may mislead or may misguide them, especially from the family members, if they are not much educated, or if they are not much concerned or much knowledge about the scientific explanations and all those things. So the child will be accepting that whatever they are telling, the child is developing his own or her own schema he is developing. So these concepts, whatever the others are giving, that is entering. And once it is entered, what is that? If it is not correct, it will lead to alternate conception. And here, one of the most important feature of science that which the child doesn't know is the falsification. That there is no permanent, true in science. In the light of new evidences or new experiments, we can change everything. Things would get changed. So the children are not familiar with the concept of falsification. What happens is that whatever they are getting in the beginning, they feel that this is the correct knowledge or this is no knowledge. So they will find it difficult, or they may feel that should not be changed, or they will find it difficult to change that. So once they are adamant, or once they are not able to change these kind of alternate conceptions, what happens is that when they enter into the school with these alternate conception, they will try to make out sense from whatever is being taught from the existing schema, whatever they are having or whatever knowledge they are having. With that, they wanted to use their knowledge, whatever they are having, for learning the science, whatever they are learning now. And when these alternate conceptions, whenever it is operational, they cannot understand the reality, whatever they are trying to learn, or whatever the concept the teacher is teaching, they will try to fix it in this framework, whatever the existing framework is there they are trying to fix it. When they try to fix it in the existing framework, what happens is that it will lead to a kind of disharmony or inequilibrium or something like that, you can call that. So their motivation level, or they will not be able to get a satisfactory answer to or their curiosity or their interest will be gradually will start coming down, and their motivation level will come down. And because they may not be able to feel the charm of science when these alternate conceptions will work out, when the alternate concept works. Then what they have to do, because everything is related, or everything is depending on their further performance or the promotion to the next class and all those things. So rote learning will take place. This is what will happen. So rote learning will take place, and whatever information they are getting, they are trying to incorporate into the existing knowledge, whatever they have learned long back, or whatever alternate conception they have long back. To that, they will try to fix everything. Since it won't fix properly, they cannot have a better understanding of the science. Then what they will do, they will start rote memorization. They will learn it, they will read it, by heart it, and vomit it in the examination hall. This is what will happen. So that will be the outcome. And again, you can see that the students, whoever is passing out from the school levels, you can see that those who are opting for the science stream are comparatively less, because we may say that they are not getting the logic, or they don't know, they are not able to manage with the scientific facts and principles. Because what happens is that this is because these alternate concepts we are not able to handle. One of the reasons, not all the reasons, one of the reasons is this one. We are not able to handle the alternate conceptions in a proper manner. So these alternative conceptions, we can classify them. All these, there are five ways we can classify these alternate conceptions. Different types of alternative conceptions are there. One is the preconceived notion. Preconceived notions are from the everyday life, whatever we are getting, but without any evidence. The inputs, whatever we are getting from that, whatever idea the child is making, these are known as the preconceived notion, a type of alternate conception. Preconceived notion, like all the acids are highly corrosive. Acids are corrosive. Everything, like even citric acid, even that they will not say, like citric acid is also corrosive. For them, everything is corrosive. Then the second type comes from the non-scientific beliefs. Non-scientific beliefs is actually coming from the sources which are non-scientific. That means it is just a kind of a generalization which is being made from without any evidences, or simply it is being made. So in science, you can see that people used to say that those who are from Israel, or the Jews, they are much more, or they are very, very good in science, or something like that. There is saying, or the Europeans, they are better in their deals and all those. These kind of things are coming from the non-scientific beliefs. So many things will come. So, but these are our concern, or our discussion is mainly related to the science. That is why these are the non-scientific. So preconceived notions are there, non-scientific beliefs are there. And this is one of the things which is very important, the conceptual misunderstanding. That you can clearly understand from the cartoon or the pictogram which I have given over here, or the infogram I have given. You can find it from there. It is, you can just read, if you can read that. We decided to make today causal Friday, not casual Friday. So that difference, you can see that causal and casual. This is the conceptual misunderstanding. That means the concept itself, the child is understanding the concept in a different manner. When the sodium and chlorine are held with, or sodium and chlorine are held with covalent bonds, or the antibiotics, even this, the second one, antibiotics kill virus and bacteria. I have seen in even highly educated people are also having these kind of notions. It kills the virus. These are the conceptual misunderstandings. So this conceptual misunderstanding creates a lot of problem in learning science. Then comes the vernacular misconceptions. This is happening because the words in our mother tongue, or in our usages, the words or the language, whatever we are using, is clashing with the scientific explanation, or the scientific terminologies. Sometimes this happens. So this clash, or the everyday life and science, when it comes together, this kind of a problem will arise, and that leads to vernacular misconceptions, like acid attack. Acid attack in science means something different, and in normal or day-to-day life or the social life, it is different. And significant result in statistics is different, or in science is different, and significant result in normal day-to-day affairs are different. Two things are different. So this is vernacular misconception. And comes another one is factual misconception. That factual misconceptions are the ideas which the child is getting from their childhood, and it is being kept on carrying till the adulthood without any change. Like all the synthetic chemicals can cause cancer, or you can say that this one, all the sugars are bad for the health, or blood, this one, lightning never strike in the same place. So many things are there. These are called the factual misconceptions. So alternative conceptions can be classified into these 5 different types. Out of that, you can see that the conceptual misconceptions, or the conceptual errors, or the misconceptions caused because of this conceptual misunderstanding, are hindering the learning. Other things we can correct, vernacular or factual we can correct, but this conceptual misunderstanding, it is very difficult to identify and correct. And preconceived conceptual, as the three types of alternate conception, like the preconceived notions, conceptual misunderstanding, and the non-scientific beliefs, the teacher's intervention can help to change them. Out of these 3, the most important one is the conceptual misunderstanding. It completely blocked the learning, and the child could not be able to learn further. And this alternate conception, when there is an alternate conception, it will lead to the cognitive conflicts. This is again psychological term I am using, cognitive conflicts it will be leading to. And that is explained in the picture, that when I know it is wrong to steal, but then why Robin Hood is a hero? Robin Hood is a thief, and how he can be a hero? So this is the cognitive conflict. So this conflict can be resolved in several manners. So how these conflicts are being resolved depends on the way the conflicts are being resolved. We can see that how the alternative conceptions can be removed or not. So here you are coming across the cognitive conflicts. So here you can see one more example I have given. The sun rises in the east. We all have learned when we are, or heard about this one when we were children, very young children. We used to hear this one. This is an example of naive concept, and it is coming from that. It is not completely contradicting, but from there you can work further. So sun rises in the east and sun sets in the west. But when we are looking from the scientific perspective, it is actually earth rotates and not the sun. So these two things, when the naive concepts and the scientific concept, when comes together, there will be a conflict. There will be a conflict in the child, because teacher is saying that earth rotates, but my mother or my father is saying that sun rises in the east. So it is not the earth, but the sun. So this leads to the cognitive conflict. So here we'll be coming across a theory called the schema theory. Schema theory was Bertland's theory, and afterwards it was further developed by Jean Piaget. Piaget has been developed this theory further. I mean, extended or related studies were conducted by Piaget and all those things, like modification. So this theory, this schema theory, it speaks about two aspects like assimilation as well as accommodation. So two ways this cognitive conflict can be resolved. One is through assimilation and another one is through accommodation. When we are saying assimilation means, like the example itself says, a child is having a habit of banging everything on the table. Suppose the child is having a banging habit. He will bang everything. One thing he has banged, there is no problem. Okay. Then another thing he has taken, he banged it. There is no problem. So what is happening? It is assimilating. So whatever things I am getting, I can bang, there won't be any problem. Third thing he is doing, banking, no problem. So every inputs or about each and every objects, whatever he is banging on the table is being assimilated into one particular scheme. And that scheme says that you can bang everything, or this is the way. So here what happens is that the new information, whatever the new information is coming, it is being assimilated into the existing banking schema. But now the child has got an egg, a raw egg child has got, and he is banking that. But now the things have changed. Now the things have changed means he used to bang, there was no problem at all. But here now he banged, what happens is that it has been broken. So here assimilation will not work or should not work. The conflict has been taken place. And here the new object, whatever he has banged, it is not fitting to the things which he has banged so far. So he is creating or he is developing a new scheme for that. That means there are breaking things. There are non-breakable things which I can bang, and this, if I bang, the things will be breaking. That is accommodation. So when the new knowledge comes, which is more scientific, the similar way, this is a simple example. In the similar way, when the new knowledge comes and which doesn't fit to the existing knowledge, whatever the child is having, whatever the alternate concept the child is having, the child should not try to assimilate it, but he has to or she has to accommodate it into a new scheme. So this old scheme will go. The new scheme will get, or the new information should be accommodated into the new scheme. And here comes the role of the teacher. And the teacher has to work to develop or to help the child to accommodate this new knowledge. If the teacher could be able to do that, then what happens is that the learning would be much easier in the sense the science learning would be much easier and much interesting. So assimilation should not take place, should not happen in case of alternate conception, but it should be accommodation. And now we'll be coming across how we can correct this one, or what we can do. We know that there are misconceptions, alternate conceptions are there, but how we can do that, or what we can do that. Many a times what happens is as teachers, we may be rushing through the syllabus, we may be trying to complete the course, we may be having 60 students or 40 students in the classroom, we may not be getting time to interact. So this happens. So, but within that limitations, I'm not going to give you an ideal situation. No, it is not possible. Whatever we are, in which situation we are having, we have to go ahead with that. So here, as far as possible, as a teacher, when we are interacting with the children, we can try to understand or identify the alternate conception. Identify. Here, the 3 C's are working: catch, challenge, and change. So identify the concept. Alternate concept. Whenever we are teaching something, if it is magnetism, if it is about acids and bases, if it is a chemical reaction, if it is the corrosive nature, whatever it may be, when we are teaching something, try to identify the alternate conception which is present in the children. We'll be coming how to do that. Once we are able to identify the alternate conception, whatever is present, then we have to allow the child to confront with that particular concept, alternate concept. उसको confront करना है. We should not leave that as such. नहीं ये गलत है. ऐसा करके भी छोड़ना. Don't leave it like that. It should not be like that. What you have to do is you have to make the child confront with that. Then once the child confronts with that, then the child could be able to understand that whether it can be accommodated or assimilated, or whether it can be fit into the existing knowledge, or whether it has to be developed as a new knowledge. The child would be able to understand. Then we have to ask the teachers, we have to help the child to reconstruct the knowledge in a more scientific manner. So this is catch, challenge, and change. These are the three words, three C's: catch, challenge, and change. So how can we identify, or how can we catch the I think some message I have received.
That is by mistake, I guess. You can
Oh, it's okay,
continue.
it's okay. So how can we catch? Catching is actually identification. So for identifying this one, normally in the classroom, when we are teaching in the classroom, let us give chance to the child in between. Let us give chance to the child and let them, or give a bit freedom as far as possible. I'm not saying that you should give everything freely, completely freely, and not like that. Whatever situation we are within that, we allow them to ask questions. When we are giving that freedom, then only the child will ask question. Otherwise, the child will never ask the question. We know that. We all know that. So ask them the question, or allow them to ask question. Instead of asking them question, allow them to ask question. And whatever explanation, if they are, or when they are discussing, or when they are asking, listen to the answers, or listen to the ideas which they are bringing. Listen to the idea. So once their ideas we are able to understand, or when we are listening their ideas, then we can see that where the problem lies, or where is the problem. And we can also ask questions. There is no problem in asking, but that question should be focusing to identify the problems. Here we can see that there is a thing called concept cartoon. I don't know how many of you are familiar with this one. Some of you may be familiar. We are having a concept cartoon that can be helpful for the diagnosis. It is standard concept cartoons are there, but we can also make the concept cartoon. If you have noticed my first slide, it was there in the first slide. We can also make this one. So once we are able to identify the alternate conception, then it is confrontation. Confrontation means it is challenging. Challenging means, here, as far as possible, ask the why question. Why this one? Why this is like this? How you are doing this one? So let them defend. We are asking questions. As teachers, we are asking questions. We are asking questions. But for that, for asking questions and all those things, we should have, before, when we are teaching a concept, we should have an idea about what are the, or somewhat, or a kind of idea about what misconcept, or the alternate concept, or the naive concept that the child could be able to bring into the class. Especially naive concept would be the maximum. Naive concept and factual misconceptions would also be there. So we should have an idea what are the misconceptions, or alternate concepts that the child could be able to come. So whatever it is, we have to, once we identified that this problem, or this is the area where the child is having an alternate conception, try to ask questions. Try to ask him to justify or defend his stand, or her stand. Defend her stand. And this one, while defending her stand, if she's, or if he is not able to defend her stand, then automatically the child will find the disequilibrium. When the child finds the disequilibrium, he will try to, or she will try to assimilate or accommodate, or probably it will go to accommodation. And again, here the child's previous knowledge would be of helpful. We can ask them what they know about, say, for example, atoms, the models of atom, what we are knowing about it, or the rotation and revolution, what we know about it, what the child knows about that, or energy, what the child knows. So the previous knowledge, if we try to find out, then it will help us, or the teachers, to challenge these misconceptions or alternate conceptions. Once it is challenged, or here the challenging can also be done not only by asking questions, allowing them to do the experiment, or hands-on. They can refer the books, allow them to go read the books, allow them to see the videos, or whatever it may be, whatever is suitable you are feeling, you can do that. So hands-on, when it comes, they are constructing the knowledge instead of telling. So once it is being caught, or once it is challenged, then we have to reconstruct. Like the conflict we have to create. When the child is not able to defend his idea, then automatically this cognitive concept will come. Then once the cognitive conflict comes, the child could be able to understand that, okay, I'm not able to defend my idea. So there is something wrong in my idea. So here the teacher has to support the child. Teacher has to support the child by providing the scientific explanation. And here the teacher can give the answer to all the why question the teacher asked in the previous stage, or in the challenge stage, teacher has asked some why question. If the child is not able to answer, now here in the reconstruction stage, the child can, the teacher can give the answer to the child. Then now the accommodation comes. So if it is properly done by the teacher, then it will be accommodated, it won't be assimilated. So once it is being done, accommodated, then this new knowledge will come and the misconception gradually will go off, because that schema the child is not using now, because the child understood that things should not be assimilated to this existing schema. It is wrong. So the child will change that. Then the new scheme will take place, or which is the true scientific concept, not the alternate concept. So here I have given some examples which the children are bringing as the alternate concepts into the classroom, like air and oxygen are same. This is one alternate concept. Or heat is not a form of energy. Ice cannot change the temperature, or the temperature of water keep on increasing during the entire boiling process. Then gases do not have mass. This is another. Gases do not have mass. Then whatever organic you are telling, all the organic materials are, all the organic materials are natural. Then polymers, all the polymers are synthetic. Always it is synthetic. Or polymer is a long chain which is having all the identical units. This is another alternate conception which the child is bringing to the classroom. Then food is excuse me, please mute your mic.
Participants, please keep your microphones and cameras off. It has been requested number of times. Mr. Masrurul Bari, may I please request you to turn your camera off? Kerry sir, please carry on.
Yeah, thank you. So these are some of the misconceptions. Or heavy water and hard water, these two are same. Heavy water and hard water are same. Then hydrochloric acid, HCl, is an ionic compound. So many are there. Then energy is, energy can be completely used. Normally we know that it is changing from one form to another, but energy can be completely used. These are some of the alternate conception. Even general life, maybe I don't know whether it can be fit completely into alternate conception, like walking in which side of the road. It's a kind of alternate conception, because when even in this college or university, when we are asking, the children are giving different options, like some saying right, some says left. Don't know what is working over there. So basically it is facing the traffic, you have to walk. It is not related to science, but the children are bringing these kind of different types of alternate conceptions the children are bringing into the classroom. So these are some of them which are related to science. So many are there. So when as the practitioners, you will be coming across these kind of situation. But how to deal with that, that is the only thing I'm just telling. This again, I have given some more and I'm just running short of the time. So regarding conservation of mass, about acid and base and all those things, state of matter, so many things are there. Even the glass, regarding the glass, whether the glass is solid, some says that it is solid, some says that it is liquid, whether it is amorphous solid or liquid or solid, that pure solid or amorphous solid or liquid, that the students are not able to, or they are having different types of concept over here. So identify and catch that. So here I have told that in the beginning, I have told that concept cartoons can help a teacher to identify these alternative concepts or the misconception. It is nothing but a concept is being represented, scientific idea or a concept is being represented in a cartoon, and in the cartoon there will be several people. This is an example. Several people will be there, and each people will be presenting their own idea. This I have taken from Millgate House. It is copyrighted material and you cannot use it directly, but you can develop your own concept cartoons, and you can use it in the classroom. Just as an activity, you can use this in the classroom. So here you can see that different children are having different opinions. They are expressing their different opinions. And what do you think? You are asking one of the child what you are thinking. So either they can go with any of these ideas, whatever is being expressed by other children in the cartoon, or they can come out with their own idea. Then looking into that, the teacher could be able to tell that whether the child is having an idea about this reaction, exothermic and endothermic reaction, or when the burning of the candle, whether it is an exothermic or endothermic reaction, whether the child is having an idea or whether the child is having an alternate concept over here. This is possible to identify. That is one. Then here I don't know whether I have, okay, this one I have not showed you. So here it actually helped the child to engage in the activities. So by after engaging into the activities, this will be coming as a result. From here we will be getting a result. Then the ideas, you can ask the children to discuss the ideas. Each child in the concept cartoon, you can see that different ideas they are expressing, and that can be discussed here. That can be, while discussing each these ideas, we can understand that what lead to the child to think about like this, what lead to the child to think about like this. So once the child is thinking in a different direction, or which is not scientific, then we have to identify that, and that after identifying, we can allow the child to explore it. We know that the exploration will help them to construct their own knowledge, and then let them discuss with their peers. You give some 5 minutes or 10 minutes if possible, especially the major ideas in science, major ideas, because that will be helpful for their future learning. Otherwise we will not be able to get them as a good scientists or good science learners. Then regarding another example I have given, this is again from the Millgate only I have taken. This is not the one which we can use. We can develop our own, or even some kind of questions like a small sheet you can give instead of this concept cartoon. Small sheets also you can use, but this is really good, really nice in the sense the children will enjoy these kind of things, like what is the speciality, or how the acid rain, or what are the character of the acid rain. This is being explained here. So these kind of concept cartoons can be used to identify, to catch, to challenge, and to change, or to catch. First stage ke liye, this is very useful. These concept cartoons are very useful. So using these kind of concept cartoons, we can identify the alternate conception. Once we identify the alternate conception, then challenge it, and then change it into the scientific notion. So once the child get the idea, the pure idea, or the correct idea, that this is the correct explanation to the phenomena, or this is the characters of this particular concept, or this is the process which is being taking place in this reaction or in this mechanism. So once the child get the idea, then the interest of the child will increase, or the child will get motivated to go further, but because he is having a better clarity. So this will lead better learning in science, better learning. Instead of mugging up the child with all the scientific terminologies and all those things, if you can do this in the beginning, or in the starting of, or in the when we start discussing about a concept, then from there the child himself or herself could be able to develop further. Of course our help is required, but still the interest, once the child is having interest, then our duty will, or our responsibility will come down. This is what I feel, or this is what we are feeling, that this way, if you can do that, instead of mugging up the things with or mugging up the child's brain. Because when we are mugging up the child's brain, what happens is that it will become a rote memorization, rote learning. Somehow they will pass the 10th standard, or somehow the 12th standard, and somehow everything will be somehow only. So there is no use with that. So this is all about what I wanted to discuss with you. Again, rusting. This is very beautifully they have done this rustings example. So how the rusting, this even in the classroom we can do it as an activity, or an experiment. We can do it. One side the experiment will go, classes you can take, then the next day like that, observations and all those things can be taken place. In a normal classroom we can do all these things. So this is all about my presentations today. I hope that I have not crossed the time. So that's all from my side regarding this alternate conceptions. And thank you again to all of you for giving me this opportunity to interact with you people and to discuss the things with you people. And I hope that I have clarified the things, or I have explained the things with all of you. Thank you very much.
Thank you, sir. Thank you so much. It was really very informative. And the session is now open for discussion. If anybody has any question, can use the chat box or can use the raise hand option. Any questions from the participant side? We have a request in the chat box that for the presentation is Mr. Gopal Vyas. He said he was asking for the PPT and also the representative mail ID. So anyway, the session is on record, so you'll get it in the departmental YouTube channel.
I can share the email link. I mean, my email I can share if he is asking for my email, and the material as such I may not be able to share because it is copyrighted things.
Okay, okay, sir. You can share the email ID in chat box, probably. So I guess there are no questions. So let us move on to the second lecture. And once again, I thank Dr. KV for such informative talk and for being with us and for your valuable time. Thank you so much, sir.
Thank you.
Okay, the second lecture will be delivered by Professor Ashok Kumar Sen, Department of Physics, Assam University, Silchar. The topic of his discussion is Observed Nature. It helps to understand physics. To give a brief introduction about Professor Sen, Professor Ashok Kumar Sen is a well-known name in the field of astrophysics. He is an alumni of IIT Kharagpur and did his PhD from Physical Research Laboratory, Ahmedabad. He also worked in IUCAA, Pune, and later joined Assam University, and currently he is the professor in the Department of Physics here. So I'd like to request Sir Professor Ashok Kumar Sen to kindly take the mic and sir, please.
Yes, thank you, Gulab sir. How much time you give me for my presentation?
Sir, 25 minutes for the lecture and 5 minutes for the interaction session.
Okay, thank you. I may close my camera if I find the bandwidth is very poor. So please take this talk in lighter perspective. I want to discuss science that we can learn from our everyday life and by observing nature, which sometimes we don't do. We just ignore certain things. But if we ask ourselves why, maybe we learn a lot of science from it. So, you see, we do not have to always perform complicated and expensive experiments to learn physics. At school level, we have many teachers here, school level, college level. So sometimes we think we don't have good laboratories. And at this level, I would say, yes, we need good laboratories, but it is also possible to learn physics, also science, in a more interesting and easy manner. If we observe our nature, if we observe activities in our everyday life. So the following things I have listed. You observe nature and try to understand a given phenomena. After that, I would say we should always have an inquisitive mind to ask why it happens like this. And please note, nature is our greatest and biggest laboratory, which is open to all of us, and it is free. We don't have to pay anything to observe nature. If we try to see some of the great discoveries in physics, which are influenced by everyday life activities or through closely watching the nature, I have listed a few for physics, but I know that there are plenty in other branches of science, especially in life science. I have noticed there are so many, but since I'm a teacher in physics, I limit myself to some of the great discoveries in physics, which are made simply by our experience from the everyday life. We know about Archimedes. he was asked by the king to check the purity of a crown which the goldsmith had made, and he was thinking all the time how to check it. And when he was taking bath in a bathtub, probably water spilled out, and we know now that this water is equivalent to the volume of the person who took a dip in the bathtub. So this is how we can find out the volume of an irregularly shaped body. And this gave him the idea that if you know the volume and then divide it by the weight, so you can check the floatability of different substances. And then this actually helped him to coin the term density, specific gravity, and things like that. And he learned a great physics from there. And we are all aware of this particular word, eureka. So this was learned through a everyday life experience. So this is an example, and this was before the birth of Christ. Now let us look into another phenomena. Galileo Galilei from Italy, 1564 to 1642. He used to observe sky with a lot of interest, study motion of planets and sun. Then there was an Copernican idea. 1543 onwards, Copernicus, the Polish scientist, he had this idea that sun is at the center of the planetary system, and he negated Ptolemy's idea, Greek philosopher Ptolemy's idea. But then this idea never gathered momentum. But Galileo had to fight with the learned community there, which was mostly dominated by Catholic Church. And we all know what happened in the history, but through his observation of the nature, he could finally establish the idea that sun is at the center, though he had to seek an apology from the church at that time, but modern science had learned from him. Another interesting story we know about Isaac Newton. I don't know how far it is true. Did he actually observe the apple falling when he was sitting in the garden? But we are told that from the apple tree, the apple falls towards the earth, and he had a curious mind. So he asked why the apple always falls towards the earth, why it doesn't go upward. And that gave rise to the idea of Newton's law of gravitation. Eventually, Newton also formulated other laws of motion. So this is an example how great science came just by observing nature. And this is what Newton did. Let me go to my next slide, because we are celebrating National Science Day. We know Professor C.V. Raman, who is behind this concept of celebrating National Science Day. He was traveling from London to Bombay by ship in 1921. And then when the ship was going through the Mediterranean Sea, he was wondering why the sky is so much blue. Because those days, the standard explanation was that it is the reflection of the blue sky by the sea water or the ocean water. But this bothered him. It cannot be so much blue because sky is not as blue as the sea. I mean, sea was bluer. So he was observing it closely during the time he was on the ship, and upon his return, he wrote a paper and he communicated. He analyzed the phenomena further, and then he discovered that this was possible because the light was getting scattered by the molecules which are present in the water. So it was the molecular scattering. And this idea finally helped him to discover Raman's effect, which he announced on 28 February 1928, and for which he got Nobel Prize in 1930. And we all know that 1987 onwards, this 28 February is celebrated as National Science Day. Raman also, analyzed the vibrational modes of many Indian instruments and also Western instruments. He studied the light scattering, the color of shells. Another interesting thing on which he worked, if you look at any snail, what we call shankho, shark in Bengali, if you look at it, towards you and look at all the helical turns, you find they are in one particular direction. He used to ask why in nature we don't have both the directions possible. So this is what famous Abdus Salam's work on symmetry breaking. But simply by watching nature and those structures, he was asking this particular question. There are other things related to light scattering. Now we know that this can be also understood to some extent by observing nature. At least you get a training to ask questions. For example, you can ask why the sky is blue. And now we know it is the Rayleigh scattering by small particles or gas molecules in the air. And small particles in the air, it scatters smaller wavelengths more. So blue has smaller wavelength. So that is why the sky is blue. And then again, if you ask why the sky looks red at the time of sunrise and sunset, it is the same mechanism. Light with longer wavelength is scattered less, so it comes straight to our eyes. Similar questions comes when we drive on a highway during peak noon time when air is very hot, or even we are walking on the highway and it is very hot and we see a mirage on the road. If we start asking, we understand what is total internal reflection. We teach our students the critical angle and total internal reflection. But then we can also understand this. We cite examples of this as teachers to our students. And this is what we observe. And the other thing in which Raman had a lot of interest, as I was telling, about the symmetries in nature, the conch shells. If you look towards the top surface, you see there are turns in a particular direction. And if one keeps collecting such conch shells, you will see this direction is only in one particular direction. Other directions are not available in nature. So nature has a preference for handedness. And if we try to ask why, we learn much deeper science from that. After Newton, I think I go to Einstein. Well, we find that Einstein never spent any money to conduct any experiment when he discovered the theory of relativity. It was in 1905 and 1915. The two theories, special theory of relativity and subsequently in 1915, the general theory of relativity was discovered by him.
Sir, sorry to interrupt you. I think you might have to present your PPT again.
I have to present what? PowerPoint.
You have to, your slide, you have to put your slides again, sir. There was some technical error.
Okay.
We can't see your slide.
Okay. Which slide you missed?
Sir, you stop presenting and present again. I can see the slides. There may be some issue with some other people.
It is to be presented again, share it again.
From the very beginning. Stop.
No, sir. No, sir. You just go out of the presentation and then present again.
Okay, let me try. Can you see the slide now?
Yes, sir.
Did you see the previous one where I showed mirage? This one, did you see?
Yes, sir.
Okay. About mirage you had seen already. Am I correct?
Yes, sir.
Okay, thank you. So I go to that relativity. See, in 1905, Einstein presented his special theory of relativity with two postulates. A few years before that, we had this Michelson-Morley's experiment, and this proved the non-existence of ether. Many of us, we think that this experiment gave Einstein the ideas to propose his theory of relativity, special theory of relativity. But actually, it is not that. If we see the historical development and his published papers and his different public lectures, he was aware of that experiment. But he used to ponder that what happens if we stand in front of a mirror. Suppose we are standing in front of a mirror in a train, and my back is towards the engine. So train is moving with my back moving forward. So under such a condition, will I see my image on the mirror if the train moves with the velocity of light? That type of question he had in his mind, and he discussed this question with many of his colleagues before he proposed this special theory of relativity. Finally, some idea came in his mind that the velocity of light has to be independent of the velocity of the source or observer. And if that is what is accepted, then naturally what came out was his special theory of relativity. And this gave rise to the revolutionary idea in modern physics that measure of time is relative and depends upon the velocity of the observer. This is what is special theory of relativity. And this came in great contradiction to what Newton and others thought till that time. It was not accepted by the community so easily. And then from there, one step further, Einstein formulated the case when there is acceleration in the motion of the source or the observer. And then he proposed the general theory of relativity, where the details are not needed here because details are too complicated, too mathematical, cannot be appreciated by everybody here. But the gross idea was that the space-time structure is actually defined by the mass present in it, and it is the same mass which moves in the space-time structure, which is defined by the mass itself. So that was the essence of general theory of relativity. So a lot of great science came, and to formulate his general theory of relativity, he did not take help of any experiment. Experiments were conducted later on to confirm, to verify his theory. I'll cite an example from deep in history, where you can see people used to think about nature very closely. And there is one paradox by Zeno of Ilia, which I like and I personally like, and I sometimes quote it when I find people interested. It was something like 500 years before Christ, 400 to 500 years before Christ. So Zeno had this question in mind that some arrow is moving and we want to know its velocity or its position at a particular instant of time. Then he used to ask this question: unless the arrow is made to stop, it is made motionless, how can we define its velocity or its position at a particular instant of time? And to know that it must stop. And if it stops, then the purpose is lost. It is not moving. And if it is not moving, how do you specify its velocity? So you see, this particular basic question, the fundamental question which you dare to ask today is something where we find a big parallel with Heisenberg's uncertainty principle in quantum mechanics. So quantum mechanics may be just 100 years old, but the basic or fundamental question about nature was there for more than 2000 years, 2500 years. And then there are other questions which I want to share with students or with like-minded people, that there are questions for open mind and which can open up, the frontier for modern science. For example, we can ask if the universe is infinite or finite in time and space. I mean, the question is that we live in an universe where we have stars, galaxies, and is it finite in space? I mean, if we keep moving and we do not hit the edge of the universe, or we may as well ask, is it finite or infinite in terms of time? I mean, if it is infinite in terms of time, then we have infinite past. If we have the universe finite in terms of time, then we had a definite beginning. We have some ideas from modern science, from astrophysics, from cosmology, but these questions are still there because nobody has drawn the bottom line yet. Even if it has been drawn, but questions keep coming. So if we ask this question, you see, then we come across certain difficulties. For example, if the universe is infinite, then you cannot deny second law of thermodynamics. And when second law of thermodynamics acts in an infinite universe, infinite both in terms of space and time, then second law of thermodynamics will make the entire universe featureless. And then there will be no structures like galaxies, stars. But we have structures. We have galaxies, we have sun as a star, we have many stars around us. So we come across some difficulties in accepting infinite universe. And then another information we have that iron, Fe, has maximum binding energy per nucleon. So over time, all the elements should turn into iron, but we don't have iron everywhere. We have maximum amount in the universe is in terms of hydrogen and then helium. So it cannot have a infinitely large past. It must be finite in terms of time. It must have a beginning. So for concluding such things or having ideas on such things, we don't need to look through the most powerful telescope. We can just keep asking ourselves. The habit of asking question helps to understand a lot of science, a lot of physics. And then another aspect, let us say, if the universe is infinite, then day and night should be equally bright, because there are infinite number of stars. During the time we have night on Earth, which should illuminate us, so night should remain as bright as the day. But this is what we do not observe. And this is the famous German astronomer Olber's paradox, which he put forward in 1823. And we can also ask, if the universe is finite, then why not all the matter coming together by the force of gravity and coalesce at one point? But we know that all the matter are not coalesced into one point. They are distributed. So I know the students of physics, astrophysics, they will answer, yes, there is dark energy and things like that. But these things do not come in one day through some sophisticated space-borne experiment where you have good telescopes. These ideas start coming from a simple mind which enjoys asking questions. So thank you very much. I stop here. Yes, if anything I can answer.
Thank you so much, sir, and thank you for the informative talk. The session is open for discussion. So if any participants have any question, can ask. Take the opportunity to get information. Any queries?
Yeah, I think there is a question in the chat box.
Yes, sir. Yes, sir. Can you see?
Yes.
Okay.
Is that if there is any book or material available to make the complex principle of science accessible to the children in a simple way, then kindly suggest. I think this question can be addressed to everyone, so anybody can answer. Yeah. Science, if you say science is very to know, if you want to know about astrophysics or something like that, maybe I can answer. Otherwise, anybody can answer this. Yeah. Thank you.
Good evening, sir.
Yes.
Sir, don't you think that we need to update our textbooks of our school so that students don't get the misconceptions or half conceptions of science? For example, let me give you just one example.
Yes.
In class 11 and 12 physics, we teach the students about the concept of stress and strain, the shear stress, Young's modulus. We teach them everything. We teach them the shear stress and shear strain of a rectangular block of iron. But we don't compare that with the shear stress of a eye-shaped rectangular block of iron. So that the students don't understand that even if it is manufacturing, the manufacturing cost of making a I-beam for the railways is more costly, then why don't the railway industry uses a rectangular block? So don't you think that the textbooks are actually half feeding the concepts to the young minds?
Yes, I appreciate your concern. See, this updating the textbooks, correcting it, it is a continuous process. And there are educationists for each branch of science or each branch of knowledge who do it in a continuous manner. We have professors here from the Department of Education. They can answer this particular issue in a much better way. So it has to be done from time to time. And I know there are such things where I personally feel we should correct ourselves. Like we still teach our students magnetism as a separate force from electricity. We teach, electrostatics, and then we teach magnetostatics all the way up to higher secondary. Then we come to BSc and first year MSc. Then we tell it is the magnetism is nothing but the manifestation of moving charge. Why don't we teach it from the very beginning? Then we don't have to teach things twice. First we teach the wrong things and then we correct ourselves. So there are many such issues. I think, yes, what you said is correct. But then this can be done by the educationists.
Thank you, sir.
There is a question, sir, please suggest by Mita Shri. Please suggest any simplest way to explain the topics like rotation, revolution, etc. as school students do not like any lecture-based discussions. Everything don't try to understand. They don't try to understand also. Don't mind, sir. Simplest way to explain topics like rotation, revolution. I don't know how to answer you. I think whatever textbooks we have, they explain rotation, any general physics book, rotation, revolution, we explain in a simplest possible manner because we have an axis, and around the axis we explain the rotation. The axis is fixed, or we can have a fixed point also around which something can move on a plane. So some amount of mathematics is required. And if you want to bring calculus into your discussion, then you will find similarity when you are on the axis of rotation or on the fixed point. So to what level you want to teach the students, I do not know. So I'm sorry, I cannot explain further, but I think our textbooks about this matter is doing a good job, fair job, yes. Yes, thank you. I guess there are no other questions, then I can.
Okay, sir. I guess there are no other questions. Then we can move on. And before that, I would like to thank you once again, sir, for being with us, for your valuable time and for such valuable lecture. Thank you, sir. Then moving on, we have Professor Chiranjan Bhattacharjee, Department of Chemistry, Assam University, Silchar. He will be talking on making our science classroom more inviting. Introducing Professor Bhattacharjee, he did his PhD from Northeastern Heat University, Shillong, in 1992. He has 86 publications in different peer-reviewed journals. Professor Bhattacharjee is currently serving as Dean School of Physical Sciences. So, sir, I would request you to kindly start the lecture.
Professor Shen, may I request you to discontinue your presentation?
Continue the content. Share karo. Yeah, good evening, everyone. Just give me a few seconds. I'm just trying to share my slides. Is my slide visible?
Yes, sir. You can go to full screen mode if you wish.
Okay. So a very good evening to all of you, particularly the science teachers who are engaged in the teaching of science in different schools. In fact, over the last 1 hour or so, in fact, little more than 1 hour, we realize as teachers the difficulty of students when we switch their position. Sitting tight in our chairs and listening to presentations, keeping our focus right on the discussion that is taking place is always very challenging. So today I thought that I will just try to share a few of my perception that how we should be making our classroom more inviting for students to enjoy the learning of science. So I would appreciate even in the middle of the discourse also, sometime if you raise your question, I can also try and attend this. So let us have an interactive session rather than one-way traffic, me speaking and you just being a passive listener. Because we are all in the same boat, brother, because we are all science professional and a science teacher. So we understand the challenges and difficulty of teaching at different levels. But it is a kind of sharing of our thoughts. And I will always appreciate discussion on whatever I am trying to present. So let me move on from here. So what I have tried to say that
the teaching of science is no doubt very important, but we must be also very careful about what is the science behind teaching. Though I'm not going to theorize much on this, but just a kind of a cartoon picture that says that there is a science behind the teaching of science also. There are different methods of teaching science, but I'm not going to really harp on these methods. Just to mention that we can actually have a lecture method for discussion. We can demonstrate certain things to the student, which is called experiential learning. Also, we can take them to laboratory and show them some experiments. Also, we can take them to field where they can observe the nature and try to learn something from there. Or also we can give them some project where from they learn something. And we can also give them some problems to solve. I just thought that this could be a certain basic ideas which are vital for making our teaching more impactful. Very often we start straight away with the topic, but we do not share our lesson plans. So a student must be briefed in the beginning that what kind of lesson we are going to impart. So as a science teacher, we should always tell them in advance, or maybe in the previous class, that what we are going to discuss in the next class. And also, after a topic is covered or good discussion has taken place, we must also summarize and inform that what have you learned from the discussion or the teaching. So what we call as learning outcome. So after the end of a lesson, it may go on for 2 or more classes, we must tell them with bullet points that from these discussion on this topic, these are the learning outcomes. So as a teacher, we must preset these learning outcomes from each topics or lessons. Otherwise, this is very difficult, so that students can take home after each lesson certain bullet point learning. And then while in the class, we should be always vigilant so that we can draw analogy with familiar objects or situation, which I often try to do with my own student. And I have seen that this is a very effective way of connecting to the students. So, but then we must try and think beforehand that when I'm discussing a topic, what kind of familiar objects or situation I might bring in the class to draw that analogy, because suddenly it may not come unless you prepare yourself in advance. Many a time we talk about science and scientific topic, but we ignore and we do not really talk much about the scientist who is responsible for the concept. We tend to neglect the discussion on the scientist whenever we explain a concept. So it is important that we also spend a couple of minutes in the class, wherever relevant, to show pictures of scientists. Now, one might say that we do not have ICT facility in the class. How do we show picture of scientists? Now, suppose you are talking about Newton's laws of motion. Now, one can get a printout of Newton's image. So we need to spend a little and take that A4 sheet with a print image of Sir Isaac Newton, and we can just hold it in the class to show them, look, this is how Newton looked like. Now, if we are teaching periodic table, we must try to take a picture of Mendeleev and try to show them. If we do not have ICT facility, never mind. You can just take a printout which costs about 1 or 2 rupees actually. And many of us have printer these days at our home, but we have to make use of little facility. See, school may not be always in a position to provide us with all such facility, but we as teachers, we should equip ourselves with some such items and take advantage of the current technologies. We also should try to sometime mention the country of origin of scientists and at what time in the history the scientists lived. Many a time we see that scientists have come from a war-ravaged time or from a very difficult struggling positions. So these incidents or these anecdotes of scientists can actually develop more curiosity. It can encourage students to take up science and to connect with science and scientists better. So the struggle of the scientist sometime, in a very nutshell, need to be described in the classroom. Now, still there are some questions that how can we make our classroom more inviting? I have jotted down some points, very small points. You can take a snapshot. Maybe most of you are doing that, but still, I just repeat how I take or I look at it to make our classroom more inviting. So we think outside the classroom. We should sometimes think outside the classroom. We should draw from real world. So all such, I talked about analogy to be drawn. So real and familiar situation should be brought in the classroom to explain a point. And in the classroom, we should try to be ourselves. We should not overact or we should not overreact, and we should not be under any external influence also. So whatever we are naturally or spontaneously, that is the way we should try to connect to our students. One extremely important thing I consider is to be very dynamic in our movement in the class. The physical movement that we do as teachers in science class is extremely important, because students try to connect to the science through the science teacher. So we cannot be a very sleepy creature. We cannot be very passive listener or passive speaker. We should have interest. We should have passion when we are teaching science. We should also try to plan some hands-on activities. I will just take few examples soon just to explain that what kind of hands-on activities may be taken. Of course, in a science classroom in schools, it's always not possible to show every topic corresponding hands-on activities. But some of the topics can always be based on this kind of hands-on activity. So we can take some time our students outside, maybe, and to demonstrate some phenomena or event, or also to demonstrate whatever is there in nature, maybe some rock samples or some specific geological site if it is nearby, or we can take them to a area where plants are there or medicinal plants are there. So, and because this gives them an opportunity to have fresh air and learn through enjoyment. So as I have said, that it is always very effective to show pictures if you don't have ICT facility. And then we also need to be very good observer to learn science. We can take students to museum at times. See, we can take lead actually in this regard, but because many places have some kind of museum, so it is, if it is there, then sometime we can spend some time in museum. Sometime we can take lead to arrange some science fair, and also we should see that how the library can be used effectively. We must encourage self-expression. That means we should encourage our children and students to and give them a lot of freedom and opportunity and space so that they can express themselves without any fear. And for that, we also need to be very open. And most important is that we need to engage with students. We should not simply enter the classroom, simply teach the subject and come out. And then don't look at their face, don't interact with them and don't engage with them. And that we should avoid, because if we want to reap the benefit of science and science teaching and benefit to the society, then it is important that as science teacher, we need to connect to our students, and that requires effective engagement. Also, it is on us that we should create enough opportunities for discussion so that students should feel respected in the class. They should not be under an impression that, oh, teacher has come, now I have to sit straight and tight. But we should create some relaxing opportunity for them so that they can open up and be more creative. And then, of course, we have a syllabus to follow and complete, but we can actually cover that syllabus or curriculum with a diverse kind of approach or differentiated instructions. Means the kind of instructions that instruction methods that we use, we should keep changing this method so that students don't feel bored to a particular type of teacher. Then sometimes we should give students some choices also to accommodate different interest and learning styles. So it is not that always I should dictate terms as a science teacher. Many a time, why not let students come out with some novel ideas so that, and then we allow that idea to flourish inside the classroom. So basically, we should encourage curiosity so that students can come forward with courage to ask questions that is lurking in their mind. So basically, what I mean that in the classroom, it is required to actively involve students in their own learning. So if this is my responsibility or our responsibility, that every student in the class is actively involved or not. We need to touch each and every student. We cannot teach to the students who are sitting in the front row only. So this is also our responsibility. We cannot teach only for the students who are very good. We need to teach for the entire class. So we need to help students to develop a conceptual framework as well as to develop problem-solving skills. So this it requires to promote students for discussion and group activities. So this is very important, group activities. We need to help students experience science in varied and interesting and enjoyable ways. So I just have taken up some stray examples. These examples may not always suit your kind of classroom because many of you teach at different levels. Some of you teach at class 6, 7 level. Some of you teach at 8, 9, 10 level. Some of you even teach at post 10, 11, class 11, 10 level also. So, but I cannot, in a short time, I cannot touch all these diverse type of science teaching in different classes. But at random, I have taken some simple examples that how we can actually bring small pieces of magnet and some materials which are attracted and which are repelled or which are not attracted by the magnetic force. So it could be a very good idea to bring a bar magnet in the classroom and engage students in some activity to demonstrate the concept of attraction and repulsion. So when we teach magnetism, I think we should prepare ourselves ahead of the class that we take a magnet. I'm getting some extra sound. If you can mute your mic, please. Okay, thank you. So if we can buy a small piece of magnet, which are available in the market, so I should make a toolbox or as a teacher. So as a science teacher enriched with concept, I should also plan that I have a toolbox ready, and I always carry that small tool bag or toolbox to my classroom so that I can take out small items from there, and students would be very curious to know what items are there today in the bag of science teacher. So science should not should sometime reside in bag also, so that we can actually engage students with more interest. I will take a couple of more examples. Say, for example, in a class of biology, we can actually, when we teach chlorophyll, which is a green pigment responsible for the green color of plants, this could be very naive examples, I know, but we really don't do this thing. It's very simple. We can get some plants and we can, in a mortar pestle, or maybe we can take some other kind of device, and we can just paste and take that green pigment out in aqueous solution. Just add water. You don't have to do anything. No toxic chemicals are involved. And we can actually show that chlorophyll as a chemical is present in leaf. So this small experiment, which is so environment friendly, which can be easily done in the classroom, but unless you plan, you need only water and leaf, and you can show that chlorophyll is really present in the plant. And of course, after that, you can teach the molecule, the structure, and the property of chlorophyll in a different way. But small such activity can actually incite or trigger the interest of the student. And you never know what are the inclination of students. From a small experiment demonstrated today from botany, that student can develop interest in botany. Other student can develop interest in physics. Some students can develop interest in chemistry. Some students can develop interest in mathematics. So, but you have to be have diverse kind of such small I would say small activity rather than experiment in the classroom. So when you are discussing proteins, you can actually bring certain things in the classroom, which are very simple things though, including milk and butter, and show them that these are the substances which we use in our daily life, and they all contain protein. So if you are showing them milk, you can actually tell them that this milk contains a protein called lactase. Now, otherwise, if you simply teach in a lecture-based method, students will forget that what is the protein that is present in milk. But when you actually bring milk in the class and try to tell them that there is a protein called lactase in this substance, then they will ever remember in their life. They will not forget. And of course, you don't need any sophisticated facility for just showing this. Only thing is that you need to have some preparedness. You need to have some sincerity of purpose, so that while going out for your school, you carry these materials that day. So there is a little bit of planning, little bit of preparation is needed if you want to actually deliver interesting science teaching. Now, if you are teaching carbohydrates, you can actually get some cereals and rice, etc., and tell them that these are rich in carbohydrates. So now, those of you who teach acid, base, and salt, that is chemistry, and then we just teach that acid is a such and such substance, base is such and such substance. We also teach that when acid combines with base, it produces salt, and we want our student to remember, and they forget, they have a hard time, difficult time to remember what is acid, base, and salt. But actually, you can bring a lot of materials which are available from our at our home only, and bring them into the classroom in small containers, and tell them that which are acids and which are bases. And also you can bring certain things and tell them that this is salt. So you can, some say, for example, vinegar. You can mention that vinegar contains acetic acid. The student will know from a very early stage, yes, vinegar is the trade name, but acetic acid is the chemical name. Then many citrus fruit, say for example lemon, orange juice, they contain citric acid. You can also talk about ascorbic acid, and you can talk about vitamin C. So in this way, you can make your have to get certain things which are not there in your box, but you must prepare yourself ahead of the class tomorrow. Now, suppose you are teaching the concept of pH. Now, you might just think that how will I show? So you can bring some small things. You can bring, say, fruity. You can bring, say other kind of things. Say could be lassi, amul lassi, and see small things. You can bring little milk. You can bring, and also maybe other kind of juices. And just bring small pH paper, which are available and very cheap, also available in any kind of chemical shop, a supplier's shop. And you don't have to depend on your school that they will have to give you pH paper, they will have to give you some other material. See, whatever materials I'm just trying to show you now, I don't think they all will come within 100 rupees for the entire session. So why should I depend on the school to give me that amount on that substances? Because you should have your own toolbox, own instruments to show as far as possible. Of course, costly instruments you have to depend on school. So we can actually show that how a pH paper, through a pH paper or a litmus paper, we can actually demonstrate that what is the pH of a particular substance, liquid substance. So this pH level is a measure of acidity and basicity. So they can get actually a physical idea of the concept. We can always define what is pH, but here again, you should also try and tell that who gave the concept of pH, which scientist, and if possible, you should also take a picture of that scientist to show. So these are some very small and simple things. Now, you might sometimes wonder that if I have to teach chemical bonding, then how do I teach? You usually take the board, chalk. But I think the most effective way is that if you can plan, you can use the thermocol balls. You can see how I've taken some. These are, you don't have to make it actually. These small thermocol balls are available in any kind of decorative shop. So, and they are very cheap. In 10 rupees, you can get some 50 balls, small such balls. So you don't have to struggle hard to make a ball out of a cube, as I have shown. But still, I have shown that if you give students that please make a ball out of a cube, it becomes a kind of a science project for him. But for you, you can actually collect some thermocol balls and color them either with colored pen, or even one can use colored sellotips, and then use these colored balls as to represent different atoms, and then use some bamboo sticks or mass sticks and make different kind of structures or molecules, and that can be easily done in the class without any kind of risk factor involved. So, but unless you prepare yourself, this is again very cheap. You can, with 10 rupees, this entire this class could be. You can imagine that to what level one can take this class actually. But whenever we teach chemical bonding, we do not think that how can I make my chemical bonding class much more interesting and also captivating. So little bit of thought, little bit of involvement and preparations ahead of the class can make your class, can take your class to a very, very higher level and delivering the students the best possible thing. Okay, I will just play. I don't know whether it will be played here, but I'll just try to play a video here, and for you to enjoy for a brief moment. Let's see. Oh, that video is not coming. Just give me a few seconds. I'll try and see that this video can be played or not. Few seconds.
So just play on the source.
Yeah, but actually it is not showing. We are trying to play. Actually, I have put it on the PowerPoint actually, but source is not here on this device actually. I'll have to get it actually. Just 1 minute. I'll just try and get it. Just really wanted to show that. Okay, I'll just try and play the video after 1 minute. Meanwhile, let me go to the next slide. I'll just, if possible, I will try and show you that particular video. It's in a different tone. I have actually sometime, many a time we are bounded by the curriculum, the limits of curriculum and syllabus, and we really do not cross the border of our syllabus to say something beyond our syllabus to the students. But sometime, we need to be very bold and trespass the boundary of our syllabus and curriculum and discuss very briefly though phenomena of any current relevance or interest. Say, for example, we can actually create some models of coronavirus using this thermocol balls. And or they can be engaged to make such kind of virus, and we can explain them what are these spike proteins. Now, you might wonder that, sir, these coronavirus and spike proteins are not in our syllabus. But you see, the entire world has been ravaged by the virus, and we do not know that in future what lies ahead. People are predicting every new kind of virus, and even new variant is being predicted in June. So why not? I take 5 minutes or 10 minutes out of my boundary and try to catch an item where I can be a little more bold and show them or engage them with some kind of activity in a very cheap manner, so that they will at least know that what is the kind of structure of virus, that there are spike proteins, and these spike proteins get attached to our cells, and this is how they get damage the entire respiratory process. So my idea is that we will always be within our limits of curriculum, but sometime we as science teacher should cross the boundary and catch the ball. And you have seen that these days in cricket matches, even catches are being taken beyond the boundaries to actually and then so this is there. So just I'm back with my slide, that slide. Let me see if that slide can be played now. So dear colleagues, you have been able to see the video? Hello?
No, sir.
Oh, you could not see the video?
No.
Yes, sir.
Just one second. Is the video visible now?
Yeah.
Yes, sir.
Okay, fine.
I think most of us could see.
Yes.
So you could see the video now?
Yes, sir.
Okay, so I think you have enjoyed the video. It is my deep respect and best wishes to all the women, because tomorrow is Women's Day. So we would want all women in science to perform like this. And you can, if needed, one can actually trespass the boundary and border of our curriculum to make things more effective. I'm almost coming to the end. I have received a reminder from the organizers. I will quickly brush through my slides. So even we can bring a small plant when we are trying to discuss parts of plant. So it doesn't cost us anything. Small plant can be brought to the classroom to show different kinds of parts. Many a time, many schools have microscopes, but they are gathering dust in the school. No science teacher ever visited, or of course, sometime even the headmaster or the principal is not parting with such kind of valuable things. They are only meant for showpiece. But as a science teacher, we must take initiative and be very active in bringing that microscope out of the almirah. And then using that microscope, we must expose our students to see the micro world, where we can easily show them the algae, bacteria, leaf section, and stem section. Even inside the classroom, that can be done. So this is one very important thing for the teachers. So I think this is all that I have to discuss with you today. I will. I do not think whether I have been able to connect or to all of you that how we can make our science teaching more interesting. But I need to be, while I show this and tell you this thing, I need to be equally interesting to you as science teacher. I hope I have been able to connect with you in a proper and effective manner, so that you in turn will be able to touch and connect your students. I will appreciate any kind of questions or you would like to ask at this point of time. Let me come on video if you would like to. So I'm looking forward to any query that you might be having at this point of time. Yeah, I agree that experiential teaching should be adopted by all of us as far as possible, as far as feasible. Okay. Okay, fine. I think you may not be having much query because I did not really talk much on science, but I talk on how one can touch and connect students better. So there may not be much questions. I can understand. But still, I'm here for a few more seconds. I would have loved to interact with you, some of you. Yeah. Thank you, Mashrool.
Okay, sir. I guess we do not have any more queries. So can we move on to our next lecture?
Okay. So let me then conclude here because I think we're running ahead of our scheduled time. We have other speakers lined up for this evening's discourse. So I would like to thank once again to all the participants in this evening. And also I thank the organizers and all my co-speakers in this evening session for being here. And thank you once again. So over to the organizers, Gulab Shah.
Thank you, sir. Thank you so much. Moving on to our fourth lecture. The lecture will be delivered by Professor Parthankar Chaudhary, Department of Ecology and Environmental Sciences, Assam University, Silchar. He will be talking on green approaches for a sustainable future. Professor Parthankar Chaudhary has worked extensively on dolphins of River Barak. His area of research also includes wildlife conservation, biodiversity researches, tea agroecology, etc. He also writes in daily broadsheets on ecology and environment-related issues. Dr. Chaudhary is currently a professor in the Department of Ecology and Environmental Science in Assam University, Silchar. So I request Professor Parthankar Chaudhary to kindly take the platform. Sir.
Thank you. I convey sincere respect to the organizers, especially to each and every members of physics department, our university, for organizing such a nice program. And as I understand, this program is meant for the teachers who are in the school teaching science. So they are the first set of people who train the young minds, and after this, these are handed over to us at a later stage. Basically, this is a sort of, this is a sort of interaction where how to make the students familiar with the different branches and the different approaches of science. For this, keeping that in the backdrop, this program has been organized, and I find that a large number of participants from all over the state and some even from beyond, they have joined. So this is a successful program. Now the topic that has been allotted to me is written in the background, in the back screen, that India, the green approaches for a sustainable future. Now the green approaches, whatever we have taken, whatever still we have not taken, still we have to take. So, and what is the necessity for taking green approaches? So these things will come up in discussion. If we look this year's winter season, all of you will agree with me that we had a prolonged winter this time. This was not even experienced 10 years back, 15 years back like that. That winter continued for a considerable period of time. So this is on the other hand, if you look at this, I can say that this is a abnormal phenomenon. It is although many of us love this cold weather. In other parts of the places, in other part of the places of the world, we will find that the rivers thing is happening, like that prolonged summer may take place, excessive rain may take place in some parts of the world, or scanty of rainfall may take place in some parts of the world. Uh, so these are some of the vagaries of weather, we can say. And all these are, what to say, all these are consequences of, say, because of our human inactions. Human inactions, in a single word, we can say, human inactions in the form of large-scale industrial expansion, technological advancement, then excessive burning of fossil fuel, excessive emission of carbon. So these are the things that is for to satisfy our own need, to satisfy our own greed. We are exploiting nature, we are exploiting the resources, and this is the way how the nature is revolting, how the response is given in a negative way. Now, there is a proverb in Native American English where it is said that the environment in which we are living, we must think that we have not inherited it from our ancestors, rather we must think in that way that we have borrowed it from our future generations. So while we are living, so long as we want to satisfy our greed, those things most of the time we forget, and the consequences are because of that. Now, from this date onwards, from 2022 onward, during last 1 decade or 2 decades, we have been listening about global warming. These terms have become keywords: climate change, global warming, carbon emission, carbon trading, carbon sequestration. These are the words that we have come to know. But these words are mostly said. Even 50 years back from now, or even 100 years back from now, these things were never thought of. People never, or the scientists never thought of these type of things. That is, carbon can be a subject matter of scientific study, or your global warming is happening, and because of which we will be facing problems. These things are not thought. Now, since previously these are not thought, why previously these are not thought? Because people at that point of time did not realize that climate change is happening. Now we are, over last 2-3 decades, we have been observing that these things are happening. These things are happening. Now, this is not just during these years, or even as I have said, during last 2-3 years, we have been listening to these terminologies, and which are rather a matter on which we are rather comparatively more worried, that what will happen to this future, what will happen to this planet Earth in the future and in the coming days. We have witnessed that in many metropolitan cities like Delhi, the environment has become too much polluted, thanks to your COVID situation, that it has become slightly, it has come slightly under control. But once the things are made regular, the environmental hazards has reached its peak in those places, and it will go on reaching more and more heights. Now, looking this, and not only in our country but in many places of the world where it is overpopulated, there is a body which is known as United Nations Development Program. There is another body like United Nations Environment Program, UNEP, UNDP. So these are the bodies which sits together and thinks that this type of nuisance, what is happening all over the world, these things will have to be brought down, these things will have to be curtailed. And keeping this in the back of their mind, the UNDP has made up a set of goals which are known as Sustainable Development Goals. What is that Sustainable Development Goal? In short, it is known as SDG. What is SDG? That means what? We will have to maintain, we will have to keep our planet, because we have only one living planet. In the entire solar system, we have only one living planet. If that planet becomes inhabitable, we have no other alternate area where you can go and where you can live. This is not, till now, the scientists, the astrophysicists, and the others who are working in the field of astronomy, they could not find out any such alternate planet where human beings are available or life is possible. Now, since we have only one living planet, to prevent it from further deterioration, The United Nations Development Program has taken up a set of goals. As I have said you, these are known as Sustainable Development Goals. Now, under these Sustainable Development Goals, we have a set of programs. You will get in literature that there are 17 set of programs. All of these are kept. All of these have been taken, keeping in the thinking that the environment deterioration should be prevented. Environment in whatever sectors deterioration is going on, those should be checked, and for the upcoming generations, the environment should be made clean, green, and their good survival, their healthy survival can be ensured. Now then again, on the other hand, in 2000, all the leaders of the world, they sat together, and a series of sittings took place, and this way, and in 2015, they set certain goals. They set certain goals not for 1 century, but for 1,000 years, for 1,000 upcoming years. So 1,000 means, in our terminology, it is known as millennium. So for coming 1,000 years, they have developed, they have kept certain targets, but those targets are known as Millennium Development Goal. This development will take place in this planet, but so that those developmental activities do not compromise with the quality of environment. So keeping those this Millennium Development Goals, that is in short it is known as MDG, this was taken. What are the major fronts on which Millennium Development Goal leaves emphasis? It is like that all these things are not directly related to environment, but some are related to the society aspect also. It is like that eradication of extreme poverty, number 1. Number 2, achieve universal primary education. Number 3, promote gender inequality. Gender inequality should be stopped or prevented, and women empowerment should be given. Then child mortality should be reduced. Then maternal health should be improved. Then the dreadful diseases like AIDS, HIV should be prevented. Then environmental sustainability should be ensured. And to achieve all these goals, the world leaders or the different countries should develop a global partnership. That is, one country should have a partnership with the other. So far as better health, better environment, better things are available to the inhabitants are concerned. Now, it is whatever this Sustainable Development Goal or the Millennium Development Goal is I am talking about. This is not just words which are to be kept, which are to be followed as in principle, or these have been adopted by, and that is the end of the story. It should not be like that, because this Sustainable Development Goal and the Millennium Development Goal are a direct mandate for all of us, direct mandate for all the inhabitants on this planet Earth. And I must say with a happy note that India is achieving in those targets, or India is working towards that direction to achieve the desired target. And as per Niti Ayog's report, we have seen that India's overall score on all these 17 Sustainable Development Goals have increased from 60 of 2019 to 66 in 2021. So over a period of 2 years, our score has increased by 6. Maybe in the coming 2 years, again we will be going from 66 to 72 or 75, like that. Now, that means what our government, our central government, to say in general, or the different state governments, they are working towards achieving those goals which have been developed by United Nations Development Program, which in short is known as UNDP. And state to state, in every state, these activities are going on. And so far as the categorical programs like your clean water and sanitation is concerned, so far as clean energy is concerned, And many of the states are pioneer. They are they're the forerunner. And speaking state-wise, so far as this UNDP targets achievement is concerned, the first can be called as the Kerala, followed by Himachal Pradesh, followed by Tamil Nadu, then Andhra Pradesh, then Goa, etc. These are the states. Now, to achieve the targets, the global targets, as has been said by UNDP, then by 2030, so UNDP has set a target of 2030 that we should achieve these things. And India is also collaborating with other leading countries so far as these sustainable development targets are achieved. Then another thing is that the topic of this discussion is what are the green approaches we have been taking for a sustainable future. All of you have heard in TV and radio that in the conference of the parties that was held in Glasgow in November 21, our Prime Minister represented our country, and our Prime Minister Sri Narendra Modi, he has given or he has declared that these are the 5 things that our country will do. What are those 5 things? He said that by 2070, maybe 48 years from now, India will be a zero emission country. That is a big target that we have kept. We will be having zero emission country. That means our country will not produce any pollutant. No pollution will be produced by our country. He has said, okay, fine. There has been some negative criticism also in some of the newspapers. I'm not going into that side, but this is a target, and all of us, if we work, the Prime Minister is the head of the country. Whatever he said, if all of us in a micro level we work on a small things, then I think we can achieve that thing. Although there are sufficient times. So this is about the 2070, and keeping in the word keeping the year 2030 in the backdrop. Prime Minister has said that India will bring its non-fossil energy capacity to 500 gigawatt by 2030. He has also said that India will bring its economy's carbon intensity down to 45% as compared to the present 100%. He has also said that India will fulfill 50% of its energy requirement through renewable energy. That means our petrol and diesel, as of now 10% ethanol is blended. So they are ethanol or any other renewable energy, proportion will be 50%. And he has also said that whatever carbon emission is concerned, which is a matter of great concern, if we look at the past 50 years or so, the graph is like that, the carbon is on steep increase. So he said that by 2030, the projected emission of carbon by our country, that is India, will be reduced by 1 billion ton. So he has said, Prime Minister has said, keeping with the assurance that our people, the countrymen, will work in such a way so that these targets are achieved. It is not that he has said and that is the end of the story. Different sectors who are working in the field of environment protection, like your MOEF, CC, and all others, they are working. They're giving different projects so that we can work. It is not the business of the Prime Minister only. It is the business of each and every citizen, so that whenever our sons, our grandsons will be coming, or whenever the grandson of our son will be there, during that point of time, the environment of our country remains clean, remains free from all type of pollutant and all these things. Now, thing is that our motto of green approaches for a sustainable future has achieved, as I have said you, to a certain extent, and we are working in that direction. Still, why we are thinking about the green approaches as on date? What are the matters that has led us to think about the green approaches? Because as I have said you in the middle of my talk, that carbon emission, if the carbon emission is constant, because rise in carbon dioxide is directly proportional to rise in temperature. If we take historical data, you'll find and plot in a graph, we'll find that whenever carbon dioxide increase has taken place, rise in temperature has taken place. Whenever carbon dioxide decrease has taken place, fall in temperature has taken place. So rise of carbon dioxide, rise and fall of carbon dioxide in the atmosphere is directly related to rise and fall of temperature. That means what? We are using excessive carbon. From what sources this carbon is coming? These are coming from automobile exhaust. These are coming from our comfort gadgets like your AC, fridge, etc. Okay. Now, as I've said you that for our own safety, for our own pleasure, for our own comfort, we are doing these things. And 100 years back, number of ACs are very microscopic. 100 years back, maybe it was not there. 150 years back, it was not there. Number of vehicles are very less, not only in our country, but in all other countries as well. Now, because of this increased carbon dioxide, there are countries like your US and China who are leaders, who are world leaders so far as carbon emission is concerned. Carbon emission, if we say in tons, then China is the leader. That is 104.3 billion ton is produced by China. He is in the first position, first boy. He is followed by second boy, with US, which is emitting 50 billion tons of carbon. India's position was initially, it was in the 5th position. Then it has come in the 4th position. Initially we were 5th boy, then became 4th boy. Now we have become 3rd boy. So after China and America is the position of India. That is, we are emitting 25.5 billion tons. This is the challenge in front of us. That is, we will become by 2070 zero emission country. But as of now, we are emitting 25.5 billion tons. Okay. This is a 2-3 years old data. Now it may have increased up to 27 or 28 like that. Now, of the total carbon emitted by the world, percentage share, if I speak about the percentage share, the China is sharing 29.18% of the total carbon emission. US is sharing 14.02% of the carbon emission, and our country is less, 7.09% of carbon emission. So 7.09 is much less as compared to the 29.18 as is with China. But still then 7.09 of the total world carbon emission we are emitting. This 7.09 will have to be reduced to 0.00 level by 2070. Target, that is not an easy task, and again that is not an impossible task also. Our approaches should be made environment friendly. But the target is a tough one. Okay. As I have said you, from the large number of villages form a district, and a large number of districts form a state, and large number of states form a country. Okay, so in the village level, and within the village there are a large number of small families are there. So even on a small family basis, if we start working, the teachers are there, in whatever capacity. There may be LP school teacher, there may be ME school teacher, high school teacher, higher secondary, college teacher, university teacher. We have one common term, that is, we are teachers. And another common availability to us is a set of students. So this set of students are the future generations. If we look at the age group of the present day India, we'll find most of the people are between the age of 15 to 25 age group. Now, if those 15 to 25 age group is available to all of us who are present here, now if we can orient if we can orient their mind towards the green concepts, that is, what should be done to ensure the environmental safety, environmental security, the purity of the environment. There are several approaches. Then I think not overnight, but over a period of 5 years, 10 years, then some benefit can be achieved. Okay, And for that to happen, I would request is most of the members present here at the school teachers or the college teachers at a periodic level, maybe at weekend, Saturday, there may be one class or 1 hour or 2 hour maybe allotted for the subject which is environmental awareness. Maybe neighboring area who whatever experts are there, they may be lectures may be organized, or hands-on training may be organized, or some activities like plantation of saplings can be organized within the school premises or on the two sides of a road, wherever free spaces are there. This way, the students can be made to understand the necessity for conserving the environment, and for that matter, the teachers will have to take the role. Okay, if we leave everything to the government, things will not work. If we leave everything to the government, you will see that I must say that from my observation, because I am in this subject from last 20-25 years, I have seen that if you maintain a good rapport with those, mainly the bureaucrats, then things may work, but if you go against them, the things will not work. Just I give you one example. Your country, that is our country, India, got independence 1947. So 1947, our country got independence. You add 25 years after that. That is the 1972. 1947 plus 1972. Forget about pre-independence India. In the post-independent 25 years of India, there was no rule, there was no act, no nothing to safeguard the water, to safeguard the air, to protect the animals, to protect the plants. No such rule, not a single rule was there. For killing animal at that point of time, post-independent India, there was no punishment. Okay. After that, after 1972, up to 1982, 83, most of the rules and the regulations that came into being. Means we have now the Water Protection, the Water Prevention and Control of Pollution Act, Air Prevention, Control and Pollution Act, the Wildlife Act, the Biodiversity Act, there are the Solid Waste Management Disposal Act. We have now Electronic Waste Act, which was in 2016, and Solid Waste Management rules. So these are the set of rules. We have now 20 or 22 different rules. Thing is that still in your place you find you will find that rules are there confined to the legislation, confined to the books, but whenever a vehicle is going emitting black fumes through its chimney, there is none. The pollution control board is there in every cities. There is none to monitor that. Whenever particulate matter concentration in any city is in high, even in our cities like Silchar or Guwahati, okay, there is nobody to check this on everyday basis. Ultimately, what happened? What I mean to say that laws are there, but if the enforcement component of this law is ignored, society cannot get the benefit. That means what the people, the bureaucrats, the others who are there, they should be made or they should be convinced so that these rules are followed in letter and spirit. Then only the society can get the benefit. Okay. Thus, this is the duty of the common citizens. As I have said you that our teachers at various levels, they should train the young minds so that we become environment conscious. So you, from your observation, you know that where consciousness is more, there the bureaucrats will also act in a more alert way. So if we make our students more conscious, then perhaps this is the way where we can avoid the damages that would happen or that are happening to the environment, and thus in a short scale, on a short scale for now, and if this practice is continued for subsequent years, also for the forthcoming years, all those environmental nuisance can be prevented. So our duty, I thank the organizers of the physics department that on the National Science Day, this is a deferred program. In the beginning, organizers have said that it is not a one-day activity. It is not just on 28th of February. It is, we can say, for we who are dealing with the science activities. For us, it is a 324 cross 365 days activities, and every time, every moment, we should think about how science can be used for the betterment of the human being in whatever capacity. Let it be in the branch of physics or chemistry or botany, zoology, geology, statistics, whatever. How my concept or our concept can be used in a better way for environmental sustainability, how in a better way we can ensure clean environment, green environment for the upcoming generations. I think I have talked a lot, and I have ended the allotted time to me. I like to stop as of now. If there is any query, I will be happy to interact.
Thank you so much, sir. Thank you for all the technical details. It was very informative. So the session now is open for discussion. If any participants have any queries, feel free to ask. So I think there are no queries. So in that case, I once again thank Professor Chaudhary for being with us, for your valuable time, and for the nice lecture. Thank you, sir.
Thank you.
So moving on, we have our last talk of this event, which will be delivered by Dr. Ramkumar Mahato. The topic of his discussion is methods of teaching science at school level. Dr. R.K. Mahato's area of interest lies in science education and educational research, teacher education, etc. He did his master's in physics and currently working as an associate professor in Assam University, Silchar. He has authored many research papers in peer-reviewed journals. So I request Professor R.K. Mahato to kindly take the platform.
Thank you. Respected faculties of School of Physical Science, all the participant friends, I thanks organizing committee, particularly Atri ma'am, who given me chance to be here. So give me 2 seconds, 2-3 seconds to show the slide. So. No. My topic is methods of teaching science. Actually, according to Dr. D.S. Kothari, the chairman of Education Commission 1964-66, his remarks about the method teaching science, that is to learn science is to do science. There is no other way of learning science. Similar feelings by Confucius, the Chinese philosopher, that I hear, I forget, I see, I remember, I do, I understand. So, in my presentation, I will try to cover following topics, that is, what is science and teaching of science, general teaching methods, guiding principle for selecting teaching methods and physical agents, methods of teaching science, traditional methods, discovery methods, other methods. At first, what is science? Actually, there are so many definitions related to science, but in a simple way, I think that science deals with presentation of fullest possible facts with least expenditure of thoughts. No doubt, other definitions are that is systematic knowledge of anything which can be experimentally verified. So many definitions are there. But as a science student, I think that science deals with presentation of fullest possible facts with least expenditure of thoughts. For example, at class 9 and 8 level, we are teaching at the school level that force. That is, a force is equal to mass into acceleration. But that is in formula we are writing F equal to ma. This is a very, very small formula, but it tells a lot. It tells a lot. So similarly, other things are there, but it requires a lot of understanding. That part I will discuss. Then, whatever the methods of the teaching, actually method is not syllabus, but it makes the topics or concepts, or that is a topic, subtopic, whatever, easy, interesting, so learners can understand. So when we are going to select a method, we must ensure that students can hear, students can see, students can speak, students can think, students can do. That is the guiding principle of selecting teaching methods and physical agents. When we are going to select any methods to teach science, we must think 100 times that it must be understanding and interest of the learners. Second, aims and objectives of the teaching. Means whatever we are going to teach, what objectives we have set, that and what methods we are going to adopt, so must be linked each other, and that must be based on the interest of the learners. If learners will be interested, once it is said that if learners are motivated towards the subject, then half battle is on in the classroom. So it is said that as more and more sense organs are utilized by the students during the teaching, learning will be more. Actually, classroom is not a place of boasting on the part of the teacher that I am master, so that is a double master degree or this, that. Actually, whatever you are teaching, luckily or unluckily, if you got the job of the teaching, if we got the teaching, came in teaching profession, our main objective is maximize the learning. How can we maximize the learning? Means learning on the part of the students is maximum. So try to, whatever the methods we are going to adopt, we must try that maximum sense organs of the learners must be utilized. Like that is, these are the physical agents, that is a hands, eyes, ears, mouth, nose, tongue. That is the hands, learning by touching and doing. The eyes learning by observing, the ears learning by hearing, the mouth learning by saying, the nose learning by smelling, the tongue learning by tasting. No doubt, in all the concepts, topics or subtopics, all the sense organs may be used, may not be used, but try to, that is a select such method in which maximum sense organs may be used so that learners can understand properly. There are so many methods of the teaching, that is traditional methods, discovery methods, other methods are also there. For example, in case of traditional method, lecture method, demonstration method, lecture cum demonstration method, laboratory method, that in case of discovery method, that is scientific method, project method, problem solving method, heuristic method, inquiry approach. Other methods are discussion or interactive approach, programmed instruction method, individualized instruction method, teacher-centered versus child-centered method approach, activity approach, process approach, environmental studies approach. So many approaches, methods and approaches are there. I will not go in detail about all these methods because shortage of the time, but particularly I will focus about teaching of science. Teaching of science having majorly two aspects, that is some are concepts and some are skills. And on the basis of research, it is found that concepts are best learned through child-centered approach, CCA, and skills can be learned with TCA, that is a teacher-centered approach. So let us have a slight examples, some examples, and slight explanation about CCA and TCA. Here, child-centered approach refers to maximum that is our methods should be such that in which child's involvement is a maximum. And teacher-centered approach refers that is a teacher's involvement is a maximum and students are getting less time. For example, lecture method. On the basis of observation of 1000 classes from class 1 to 12, it has been found that 95% time teachers are dominated in the class and only 5 or less than 5% times students are getting chance to interact with the teachers. So if involvement of the learners are less, particularly at the school level, where that adolescent learners are there. So they loses their attention, they loses their motivation, and learning among the learners are less. For example, plant is a concept, and to know the different parts of the plant is a skill. Other example is, for example, the temperature is a concept, and measuring temperature or reading a thermometer is a skill. Other example, photosynthesis is a concept, and performing photosynthesis experiment is a skill. So, suppose that at class, I am taking one example of teaching science at class 6 level. That suppose that a science teacher is teaching air. So it can be best taught with the help of child-centered approach, and learners can understand in a easy way, in a interesting manner. So that is this concept here. Suppose that teacher will keep a problem before the students. Problem: does air have weight? This problem is kept by the teacher. here involvement of the teacher is there. Then if the problem is kept by the teacher in a classroom, then learners will think, give the responses, that is called hypothesis. The students may tell that, yes, sir, air has weight. Some students may tell that, no, sir, air has no weight. Some may be undecided. So this is hypothesis. So this is a given by the student, that is student participation. Third step is that is experimentation to verify the hypothesis. That is students will be given empty balloons, very low cost, minimum cost. So, and students will be asked to weight these empty balloons with the help of a spring balance. Suppose that weight of the empty balloon is 5 grams. Then all the learners are allowed to blow the air inside the balloon and weight the air-filled balloon. Suppose that the weight of, and they are asked, that is after weighting, that is calculation may be done. That is, suppose that because it's lower classes, that is weight of the air-filled balloon equal to 10 grams, weight of the minus weight of the empty balloon equal to 5 grams. After subtraction, that is 5 grams is there. Then we may ask to the learner, what is this 5 grams? Then certainly the learner will draw the conclusion that, sir, the 5 grams is a weight of the air. Hence, result or inferences or conclusion, they may draw themselves that yes, air has weight. So we may see that here involvement of the learners. There are 4 steps. That is a problem that is kept by the teacher, hypothesis made by the students, experimentation done by the students, conclusion drawn by the students. Suppose that each sector is 25% of 100, then only involvement of the teacher is 25%, and remaining the 75% is a learners' involvement. So this method is a child-centered approach. So in this way, if we take a small experiments, these not required very costly things, costly apparatus. Really, friends, at school level, there is no sufficient facilities. So after independence, so many programs and policies came, but till now our teacher friends are struggling, that is with laboratory equipments. No sufficient laboratory equipments is there. No doubt there are so many programs and policies after independence. That is during 1985, Rajiv Gandhi, let Rajiv Gandhi circulated one paper, that is problems and prospects of education, particularly school education. And on the basis of that, new education policy 1986 came. And it was observed that at that time, all at primary level, in maximum schools, less than 2 teachers, that is single school teacher was there. Forget about that is other equipments, even that is there was no blackboard, and small things were not there. So in 1987, OBB program was launched, that is Operation Blackboard. Under this program, provision was made that the schools should have minimum facilities like chalk, blackboard, games and sports materials. Later on, DPP was, that is District Primary Education Program, was launched in 1994 to provide some sort of more benefits to the primary level. On the success of DPEP, SSA was launched in 2001, and on the basis of success of SSA, RMSA, Rashtriya Madhyamik Shiksha Abhiyan, was launched in 2009. Later on, now in 2018-19, Samagra Shiksha Abhiyan has been launched. But till now, under this Samagra Shiksha Abhiyan, that is all, that is from pre-primary to class 12 are under one umbrella, and all should get maximum benefits. But till now, teaching of science, due to lack of laboratory equipments and even manpower also, that is, there is no proper lab facilities are there. If some sort of laboratory equipment is there, no lab assistant or lab attendants are there, and even teachers are not properly trained in that area. These are the problems at school level, due to which our teaching science is lagging behind. So our teacher friends must go for, that is, low cost and no cost teaching aids. So, and try to make, this is their responsibility, gentlemen. No higher authority will compel for that. It is our responsibility that how can we make our teaching learning interesting. This is our responsibility. And suppose that that is just our earlier speaker told that that is our education system is lacking of networking. School education is functioning in a separate manner. College is functioning in separate manner. Teacher training institutes are working in a separate way. University working in a separate way. There is no networking. If networking is there, then we may be benefited. Suppose that in Barak Valley, Assam University is there. So if sometimes with networking, if there is a interaction between, like this program, really I thanks to Atri madam and faculties of physical science, they organized such type of programs may be organized frequently. And this time, suppose that they are not, this is in online mode. If they, such type of program is organized in offline mode, then more interaction will be there. And in our university, the rich laboratory is there, equipments are there, learned faculty members are there. So through interaction and observing these laboratory, we may learn more. So I think that with shortage of time, even though I will try to cover maximum, I covered maximum parts. As per either I am able to convey or not, that depends upon, that is judged by our that is participating friends. So if any question is there or any query is there, please, platform is open.
Dr. you may unmute and ask.
Good evening, sir.
Good evening.
Sir, actually, there is one problem in teaching in details, time management. If you go in details, experimentation or teaching aids, then time is a big constraint because we have a pressure of syllabus ending very quickly, and there is a serious problem, sir. I'm facing that problem continuously.
Yes. Okay. Very good question, friends. No doubt. Teaching so many things on the part of the teacher and understanding less on the part of the student. So it is better to teach less only those things. No doubt, yes, our syllabus are having many things, many things. So, gentlemen, revision of the syllabus is required, and now under this new National Education Policy 2020, that is a integration is there, means whole education system will not work in a segregated way, independently. That is all will covered from that is under one umbrella. And I think that now things will be. So try to, whatever you are teaching,
I'm teaching physics,
please.
sir. Physics.
Okay. Physics, okay, gentlemen, very good. So physics, so a small, suppose for example, gentlemen, as you are telling, for example, if you are teaching that is about flotation, law of flotation. For this, no need that is a big laboratory is required. Is it? Even in a small vessel, water is there, and paper or that is marbles. In this way, that is a small, with a small things, we can teach in a effective way manner. And no doubt, time constraint is there. But even though we may teach if we desire. Thank you, friends.
Thank you, sir.
Over to Gulab sir. Over to Gulab sir.
I think that no more question is there.
Hello, ma'am, can you hear me?
Yes, now you're audible.
Okay, sir, there was a request from Mr. Abdul Salam. He was asking to define hypothesis again.
Hypothesis. Hypothesis is a guess, intelligent guess. Just I told that is the problem is a does air has weight. So students will think and respond. That is about the solution of the problem. That is a guess. Okay?
Honey? Okay, thank you so much, sir. So if there are no more questions, so we shall move on. And here I would like to conclude our lecture session. And I once again thank Professor Dr. Mahato for being with us.
Thank you. Thanks a lot.
Okay, for your valuable time, sir. Thank you so much, sir. So now I would like to request Professor Otri Deshamukko, coordinator of today's event, to give concluding remarks and vote of thanks. Ma'am, please.
Thank you, Gulab sir. It was indeed, I mean, I was attending the full event, and I found the lectures very, very interesting. I don't know, when we look at the feedback forms, we'll get to know the comment of the participants. And as a formal vote of thanks, I would like first to thank our resource persons, all the 5 from different departments of our university, for sparing their valuable time to interact with the teachers from different schools of the valley. Actually, some of my friends actually helped me to reach them, and we could organize this small meet. But as it is coming out that there are certain needs, and if we feel like from the feedback forms that it is required they want more interactions, then we can design and organize such programs. But everything will depend on the feedback received from their end. We could not reach all the teachers. Definitely, the time was very short, and all the exams, all the schools are having exams for the children. So everybody is busy, and some people are busy with election work. And it was very nice of Mr. Chore being here. He is an alumnus I came to know during the program only. And it's very nice to see our students established in their professional fields. And we were really lucky to have him with us today. And as a like the program was conceived in such a way that we do some exercise, academic exercise at our level, at the higher level, and the more fundamental level the schools are working, and there should be a communication there, understanding everyone's need and trying to put out a helping hand, because we most of the times nowadays we have visitors from different schools. The students come and we could see in their eyes that they're very interested or they're very excited seeing the laboratories sometimes. And some schools I find that they come just like that and they are just taking the students along the university roads, and that is I find personally that it is useless and wastage of time and energy and money, everything. So it's better if you can contact the department and bring them there, and we can show them something, at least to the science departments, or maybe to the library, or maybe somewhere, but it should be planned. Just coming down to the university and taking them through the university roads, showing them buildings, sometimes doesn't look nice from our part of view. So anyway, so I thank everyone, the team which has worked, the team of research scholars, and the team of faculty members of physics department. In addition to that, Dean sir was always there, and the colleagues from education department, they have just only with one request they have agreed. And the dean of School of Education could not be here because she is busy with some other meetings. And actually, I would like to thank everyone associated with the event for making it a success. And it will be more successful if we receive feedback from the participants and we can plan some future outreach activities. Thank you all. That much from my side. It was a long event actually. Daytime we could not organize because you also are busy in your school and we are also busy in our own normal duties. So we could not organize it in the daytime. And as Professor Mahato has already suggested, a physical meeting would have been better. We'll try for that in near future. We can promise that much. And with that, I would like to thank you all. Any participant wants to share some thoughts, they can share. Or experts have already spoken. So any one of you wants to say something on the program, you can, or you are filling the feedback form. Thank you all. Gulab sir.
Thank you, ma'am. Thank you.
Thank you,
Good
sir.
night.
Thank you, ma'am. Thank you, everyone, for being with us. And we end here officially and hope to meet you soon. And